Okay, problems like this are a little bit annoying because they talk about this whole weekly thing. You would kind of assume that someone who is as serious about jogging would be jogging every day. 7 miles a week really isn't very much. But the way they've written this, I think the way you have to assume this, and I would be more clear about this on the test, is we think that the first week she actually, I'm going to call it G sub 1, the first week she actually just jogged 7 miles during the week. Then the second week, so this is someone who's sort of starting from scratch, if they're as sporty as most of you are. So someone who jogs 7 miles in one week is just sort of starting out, and that's 7 miles total for the week. Then the second week would be the 7 miles plus 5% over that. So it would be more than 7, over more than 7 by 5% of 7. We've talked before about how, yeah, I could take 7 times 5%, add that to 7, but that's kind of too many steps, and it's not going to help us in the geometric growth sense. I should do that in one step by multiplying by 105%. That's a common way to do that. We've been doing that since the logarithm chapter, back from first semester. Anyway, 105% multiplier is the way to say, well, it's going to grow by 7%. This is a one-stop shop for how to get there in one step. And just in case you want to know what that was, this is 7.35. Lo and behold, guess what? If I just wanted to find 5% of 7, it would be that 35, 0.35 piece of a mile there. But notice if I multiply by 105%, I get that all in one total, and that represents the original plus the tacked on 5% in one fell swoop. So this is 7.35 in case you want to see that for G sub 2. This problem never asked about G sub 2, but just to give you an idea. G sub 3 then would be 7.35 times another 1.05. Okay, the question is, if she does this for an entire year, how far has she run totally? Okay, so this is a sum of a series. I need to add up the first year of this, and this is, well, if we're adding up week at a time, we'd add these all up until the last week, and we're assuming there's 52 weeks in a year. I'm going to add all these up. This is the sum of the first 52 weeks. Geometric series is G sub 1 times, sum of geometric series, 1 minus rate to the n power over 1 minus the rate. I guess I already had the 52 here, so I could have put 52 there. Anyway, in this case, sum of the first 52 is the first one times 1 minus, we already decided rate was 1.05 to the n divided by 1.05. Now, some people are making a couple mistakes here on the actual calculation of that. I like to do the 1.05 to the 52 first, subtract that from 1, multiply by 7, divide by 1.05. So that's what I'm going to do. So you can see this all in one place. I'm going to take 1.05 to the 52th power, 1 minus that. And I gotta be careful. I made a mistake on a couple of videos ago about how I did all this stuff. Yes, that's a huge negative number. That doesn't surprise me because I'm dividing by a negative. Oh, see, I made a mistake here. It should be divided by that. Of course, I didn't make a mistake in the calculation, just in the writing of the formula. And that part, again, you can usually do in your head. 1 minus 1.05 is negative 0.05. Divide by that in one step, I get 1,600, and well, look at that. I'm going to say 1,630, and we'll say approximately equal to, well, it says to the nearest mile anyway, so yeah, even with to the nearest hundredth of a mile, I think we're at that whole number, which is kind of cool. Yeah. Okay. All right, if you haven't figured this out by now, 19 is one of these classic combination problems. It's a classic NCR problem. When I say if you haven't figured this out by now, here's a hint. If you haven't figured this out by now, we've only got one type of counting type of problem in Chapter 8, and there are all these NCR problems. There are always the problems where you have a certain number of things to choose from. You have R, sort of a number of R, kind of a subgroup of those to pick. We don't care about the ordering of the R subgroups. It's kind of like this. We have a test of 30 questions. You can pick any 25 of them. We really don't care in what order you make that selection of 25. It's not like a permutation where if I pick number 6 and then number 3 and then number 17 and number 8, that's different than picking those same ones in a different order. No, it's the same thing here. Basically, I'm choosing which 25 of these 30 students get to get on the bus, as I've been saying in class. Like, I don't care which order these 25 are picked in. There's not like there's seat numbers for these 25. It's just take a collection of 25 to grab out of a total of 30. So here we're just looking for 30, C, 25. If you have a count, here's my hint then, really. If you have a counting question like this on the test, you've got a big number and a small number, it's going to be big number, C, small number, and stick that in the calculator and see what you get. Now, it gets a little more difficult when there's more to it than just that, like if you've got this and something else going on at the same time. But even still, you know this is going to be involved. You've got things to choose from, how many of them you're going to choose. This one, there's only those two numbers, so this is all there is. And you get these surprisingly huge numbers sometimes. Like, really, picking 25 things out of 30, it's like picking 5 to exclude. Like, really, that shouldn't be huge. Well, it is. It's 142,506. That these do sometimes actually turn out to be kind of huge. So I mean, that's not impossible. So yeah, there you go. I mean, if you really wanted to figure this out the long way, or if you saw this kind of number like, oh really, is that true, you'd go 30p25, which is the first 25 numbers of this. Oh my gosh, it's gonna take forever. 28, 27, 26, blah blah blah, down to, I guess, the first 25 of these. The last one would be, we're cutting out the last 5, so the last one would be 6. It would kind of end like this at the very end. That's supposed to be an 8. All right. So it's a whole bunch of stuff being multiplied. So there's your ginormous numerator over 25 factorial, which is 25 on down. 25, 24, 23. But this doesn't stop at 6. This goes all the way down to 1. If I was to multiply all those by all those, I mean, I'm talking about huge numbers here, so who knows what's going to happen. That's not exactly crazy looking now. But 25 on down is going to start canceling around here, and the 6 is going to cancel down here. But what's going to be left down here is going to be 5 on down. I mean, all this is sort of still going to be here, and this is still going to be here on the top. So really, I'm talking about 5 times 4 times 3 times 2 times 1 on the bottom, and 30 times 29 times 28 on the top. And this is not very much, and this is huge. So yeah, it could be huge. And there you go. All right, number 20. Susan wants to buy 3 different soft drinks, 1 type of chips. Okay, so we're talking about a counting problem again. 3 soft drinks, 1 type of chips, and 2 different dips. The store sells 12 different soft drinks, so of those 12, she's going to pick 3. Of the chips, there's 4 kinds of chips, she's going to buy 1. And of the 5 different dips, she's going to buy 2 up there. How many different ways can she choose refreshments? Okay, I think on problems like this part's the easy part. The fact that we're doing 12C3 and etc. 12C3, that's going to be kind of big actually. 220. 4C1 should be 4. 5C2, I think I've done this enough to know that that's going to be 10, but let me just check. 5C2, that's 10. What do I do with these 3 numbers? Remember, in probability problems, and means multiply, and or, and we've had both of these even in this chapter. I mean, of course, this is way more intense in the probability chapter, but even now we've had both. Or means plus. So is she going to pick this and this and this, or is it this or this or this? Well, I think we have our answer right there. She's picking all these things. So yeah, she's going to have 220 ways to solve the soft drink problem. And for any one of those 220 ways to solve the soft drink problem, she's faced with 4 decisions on the chip problem. So that, you know, creates a multiplication situation. And then for all of that, she still has 10 different ways for each one of those answers to decide on the dip situation. So 220 times 40 times, 4 times 10, which I can do in my head, that part, and I get 88 100, which is a lot of chip dip soda combinations. All right, I think I have time to do at least one more. All right, 21. Gardener plants 20 bulbs. The probability that any given bulb survives is 0.6. Okay, already this sounds like survival versus death, 60% versus 40%. Sounds like 8-9 binomial probability. And survival of each bulb is independent. Okay, great. So thank you for confirming that. It's going to be success and failure to the power of the number of trials, which is 20. Okay, so when I expand this, I'm going to get the probability distribution for the situation of survival versus death. I don't really care about all of them. The only one I care about is the one where I have the 0.6 as the survival 15 times the 0.4 to the fifth, and I care about the coefficient on that, and really I just care about this term here. Remember, just to give you, and this is in the middle of some ginormous expansion. The first one would be 0.6 to the 20th. The next one would be plus 20 choose 1, which is 20 times 0.6 to the 19th times 0.4 plus blah blah blah. There's a whole bunch of stuff. But at some point eventually I get this one, which is, if you remember, 20 choose 5, 0.6 to the 15th, 0.4 to the 5th. So I can just compute this little probability right here. This is all numbers. I can actually do this. Another way to say that, of course, is 20C5, 0.6 to the 15th power times 0.4 to the 5th. Let's figure out 20C5 first. 20C5 is 15,504, which is good because I know these decimals are going to be tiny. Times that other junk. 0.6 to the 15th power. You know, I'm just going to do this in one step. Times 0.4 to the 5th. Times that big number. Times that answer, which is going to be altogether about 7%, which is not, which is not insignificant. I mean, 7%, it's great. 7.46%. Let me write that down before I forget it. What did I say? 7.46%. Rounded to the nearest tenth of a percent. That was this times this times this. And good for us, they said exactly, so I just want this one. If they would have said at least, I would have had to add this to all the stuff before that, which would have been like about 6 of these terms, and they all been slightly different. It would have been kind of a mess. But exactly 15 is just that one term, and that's kind of nice. All right, we're on to Form C now, and Form C, I always say, is kind of like, well, it's a little bit above and beyond what you have to be able to do for the test, but they're good to think about. I've got about 2 minutes left on this video. I think I'm going to try to tackle the first one, just to save video numbers. All right, give the first 5 terms. This is kind of a silly question because it says, give the first 5 terms of geometric sequence. Explain how you know it's geometric, because you asked me to make a geometric sequence. Anyway, first 5 terms of geometric sequence, well, they're just making me make it up, so I'll make it easy. I'll start with 2 and I'll triple it. Okay. How do I know it's geometric? Well, you said to make it geometric. What do I mean by geometric was this was the times 3 sequence as I was going down the line here. I kept multiplying by 3. Then write explicit and recursive. All right. I don't know why they ask explicit first. Explicit is the type where I'm saying, okay, if you just tell me which number to jump to in the sequence, here's the formula using that number n, the sort of address. How do you figure it out? And that's always g sub 1 times the constant ratio, which I made up, to the n minus 1 power. Now, you could probably check that if you really wanted to. Put in 1 for this. 2 times 3 to the 0th power is 2. 2 times 3 to the 2 minus 1 for the second term. 2 times 3 to the 1th would be 6. 2 times 3 to the 3 minus 1 is 3 squared. 2 times 9, oh good, 18. There you go. So that's explicit. Recursive is the 2-parter, down to 55 seconds, which I need 2 parts for, g sub 1 and g sub n. G sub 1, just here you go. And g sub n is for all the n's that are greater than or equal to 2, when n is a natural number. That just sort of explains when are we even talking about this line. G sub n is, well, take the previous one and multiply by 3. Take the previous one, I'm going to write it this way just because you might see it this way sometimes. Take answer times 3. So 2 is the first one, then from there after I take 3 times the previous one. 3 times 2, okay, there we go. 3 times 6, okay, there we go. Alright, so that's the first one of Form C. I'll see you in the next video.